Assalamualaikum. So today in MBM we continue discuss question number 7. Essentially there is a thin plate which is we can neglect the thickness of this plate been pulled between this fixed plate and moving plate, fixed wall and moving wall. So the plate, it is moving to the right with the velocity of 1 meter per second, and the moving wall, it is moving to the left with a velocity of 0.3. So been asking in question A to plot the velocity profile. So this is the velocity profile for this problem at the bottom region. As for the upper region, there will be like this. Alright, like that. So you have a velocity that going down as it is go to the fixed wall. But as for this region, the below region, since that you have two plates that moving different direction to each other, at a certain point between these two plates there will be a zero velocity, and the velocity profile getting near to the moving plate, velocity of the fluid will be increasing, and the velocity that make contact to this plate will have the same velocity to the moving plate. So that's why the velocity profile, when it's getting to moving plate, the velocity is maximum. That is, go further than the plate, the velocity will reduce. And because the different direction, there certain point will reach a zero velocity. This happen because at a certain point the velocity to the right will be at a magnitude and velocity to the left will be at a magnitude. So this difference in velocity will make the velocity at this point will be equal to zero. Find the location where the velocity is zero. So in here we will using the simple math principle, which is graphing and to find the gradient. How do we do that? In here you can see I have made a problem solving. It is my problem solving in general. Maybe you can take a picture out of it and try to understand by your own first. But anyway, we're gonna make this solution by drawing the axis, x and y axis. So imagine that this is the velocity profile for our problem, and we locate it into x and y axis, or to be specific, y is the y distance and x is the velocity. So x is the velocity and y is the y distance, and we allocate 3 points. The first point, it is at the middle, that cross at the point 0, 0. It is where the behavior velocity is equal to 0, and we make this point as our reference for y-axis. So y-axis we allocate it as a 0, and we have a second point that locate at the lower graph in here, for example. So in here, which is in this question, will be at this point. So in here I will make an assumption distance from the point, origin point, to the second point, the y distance of it I'm denoted as yb. So it is mean it will have a coordinate of y that will be negative yb, and the x-axis or the v value will be at 0.3. So there is the coordinate for below point, and the upper point, which is in here. This question, it will be located at this point. The distance from the origin to the third point, that will be ya, and this make the coordinate will be the velocity, that will be 1, the x-axis, and the y-axis, that will be yb. This is the ya. So in here I make a mistake a bit. So the x-axis, that will be 0.3, the value of velocity, negative 0.3 because it's located at a negative side, and the y-axis, there will be negative yb. So we will using mathematical principle of finding gradient. So we have two gradient that we can find between point 1 and point 2, and point 1 and point 3. So that's why in here, how do we want to find out the gradient? We need both axes for y and x. So the gradient formula, there will be y-axis first. For example, minus by yb x a lagging a bit. Minus by xb. So this is the general formula for gradient. So you just applying this coordinate into an equation. So first, let's do for point 1 and point 3. So you will get here like this, and point 1 to point 2, then you will get this side of equation. You will arrange, and you will get a relationship between yb is equal to 2.6 minus by ya. And we know that the relationship between ya and yb, it is yb, it is equal to negative 2.6 minus by ya. It is just a simple math, whereas the total value you minus by ya, then you will get yb. So you will get this relationship, and you substitute the value of yb into this equation. Thus you will get a simplified equation of ya. So in here you can solve, and you will find the ya is equal to 2 and make the yb equal to 0.6 millimeter. So that's how we answer the question A. So moving on to the question B. I cannot explain the reason why my step of work will be like this. It is because after I make my own work, the lecturer saying that it's wrong, and obviously I'm getting the different final answer if I'm using my work. So this is a solution from my lecturer. I'm just gonna explain to you the explanation that I get from my lecturer. So hope that maybe you can understand and maybe can tell me later on in the comment section. So question B, determine the force that need to be applied on the plate to maintain this motion. We know that every viscosity shearing stress of viscosity will have a shear force, and in here shear force happen at the both side, which is the upper side because you have a gap of an oil, and the lower side. So the force from both sides needs to be summed up. For example, if you want to do in the upper side, so this is the calculation for upper side. We're using an equation between relationship of nu to tau, and we can rearrange the equation with respect to force. The effect area, there will be the area that make contact into the fluid itself, which is length times by it is y. So that's why in here 0.2 times by 0.2 and times by dynamic viscosity 0.027 and multiply by it is velocity, which is 1.3. Oh, and it is for lower side and it is for upper side. 0.2 times by 0.2, 0.7 in dynamic viscosity, and 1 it is the velocity, the maximum velocity at the upper region. Thus you will get the shearing force at the upper region 1.01, 1.08. And for the lower region, the other value, for example A and nu is the same because we were dealing with the same fluid, but the value of y it is different because the distance between the moving plate and the moving wall is 2.6. In here I'm also confused. Instead of taking 0 as our reference, because it is where the zero velocity happen, they were using a moving fluid as a datum. So maybe you can explain to me why. And there is a first question, why using 0.002 instead of point from the zero velocity happen. But anyway, 0.026 as our dy, distance y, and the velocity, instead using either 1 or 0.3, using relative velocity between both of it. So the relative velocity between both of it is 1.3. You plus 1 and 0.3. So in here I don't know why did the working flow were using relative velocity, and why did relative velocity, even though you have a different direction, you need to plus by each other. So maybe you can explain to me. The second question, why using relative velocity, and third question is why we're using why did the relative velocity need to plus even though it's moving a different direction. So we are using the relative velocity as our y distance, and we are using the relative velocity for our velocity, and we were using dy distance between two moving plate as our distance, so you will get 0.54 Newton. And remember, been asking determine the force that need to be applied on the plate. So total force, total shearing force. So the total shearing force need to sum up both this force, then you will get 1.62 Newton. So I think that's all for today. Thank you for watching and have a nice day.